Hola! All right, here's the review I promised. It is 6:15, the night of the 3.5 banquet. So I'll work on this a little bit and then finish it afterwards. So I just picked some questions from the book. You can kind of read through this here. I'm reading through it for the first time. So what we have, it looks like two different buses. So I'll underline bus A. And then for six, I'll kind of squiggly line this information. All right, so obviously we have two groups of information. So when you look at this sheet, this should really help you. And think, all right, is it a two proportion or a two sample T or a two sample Z? Isn't really on here, but that could be a choice as well. Obviously, I hope you guys can tell we're not talking about proportions. We're talking about averages or means. So, and the standard deviations have to deal with these 51 buses, for these 60 buses. So these standard deviations are S. So the type of test would be a two sample t-test. Your null hypothesis is bus A and bus B are, I should say A first, and bus B are equal. And our alternative, does the data indicate a significant difference? So would be bus A is not equal to bus B. I'm going to come back to this later and have it entered in my calculator, and then you guys can check that. But I feel like you should be able to run that test pretty easily. What I'm hoping that this does is just helps you decide what type of test to use. All right, number 11. Okay, this time notice the true standard deviation is given. This is about match boxes and how many matches are in a box. So not a matchbox car, but an actual box of matches. All right, a random sample of 94 match boxes shows the average number to be 43.1. Using a 1% alpha level, can you say the average number is more than 40? So let's set up, I'm gonna put this camera down, tip in here. Okay, here we go. All right, so since the true standard deviation is given and we only have one set of data, all right, think through what we have going on here. Again, this is not a proportion. We're dealing with averages. So if you're dealing with averages, you're down here. We just have one group of information and the true standard deviation is given. So z-test, you can look at this to help you write your hypothesis as well. So a z-test for number 11. And the null hypothesis is going to be equal to 40. And the question they asked more than 40, so that's pretty easy, more than 40. And again, just type everything in your calculator, okay? Let me stop. All right, so I already went through and wrote some things down. Hopefully this sounds like proportions to you. The sample proportion of urban and suburban, I have those labeled. So this is obviously a two proportion Z. And again, I think it's helpful to label U and S because they try to say it backwards in the question. Does this indicate a higher proportion of suburban? But I have urban in first, so I'm going to use a less than sign, urban less than suburban. Obviously, you just go to 2 prop Z and run the test. Okay, so 14 can be kind of confusing because it maybe looks like you have two proportions, but really it is just one. And the reason being, the first information given is from a budget office. It's not from a sample. It's from the Wall Street Journal. This is kind of a set number that 36% of employees hold a bachelor's degree. What they did here is took one sample of 120 employees and found 33 have a bachelor's degree or higher. So does this indicate the percentage of employees holding a bachelor's degree or higher in the private sector is less than that of the federal civilian? So we're comparing our one proportion to the 36%. So this actually, the only sample proportion we have is 33 out of 120, but we're going to compare that to the true proportion of 36%. So it's a 1 prop Z test. We're comparing it to 36%, and it says higher in the private, or wait, less than that of the 36%. Sorry, read the question again. This should be less than. And again, run a 1 proportion Z test in your calculator. Okay, for number 15, if you just want to take a second and read that over, I think right here where it talks about the 8 cups of coffee from this machine show the average of 7.3 and the standard deviation of 0.5. That's saying that's from these 8 cups. So this is the S standard deviation. This is your X bar. It's supposed to contain 7 ounces, but they're afraid the machine has slipped out of adjustment and it's different from 7. So this would be a t-test. Null hypothesis should be that it's equal to 7, but they're afraid that it's now different than 7. And then just run a t-test from that. Okay, finally, sporting goods, number 17. A manager taught the store better ways to advertise and display their goods, and they have a before and after. So hopefully, if you look at this, before and after, the only one that makes sense is the match pair. And look how we write a hypothesis there for a match pair. And I just want to kind of reiterate what you would do in your calculator is you would find the differences. And I'm not going to be able to do that in my head right now, but you could just make a list right here of all the differences. And what they hope is that the sales have improved. So I'm going to put a star by the ones. So after the visit, they all improved except for store number 5. So if you have this written down as a positive number, I would subtract the 63.5 minus the 57.1. So when you write here a hypothesis, remember that D. An alternative is that the sales have improved. And you just run a regular t-test for that. Okay, so if we're asking the question, are men significantly taller than women? We don't have any data. We're not going to run any test. But the null hypothesis is that they're equal height, and are men taller than women? Suppose we did have a 95% confidence interval and it ended up being 2 to 4. What does this mean in terms of the hypothesis test? This means that since men is written first, that the true average of men is 2 to 4 inches taller than women. So that corresponds with the alternative. So we would reject the null hypothesis because both of those numbers are positive. And obviously, I hope it's obvious that from the box plot we see, you can describe the box plots how this really is showing that men on average are taller than women. Okay, in the type 1, type 2 error, I will give you the chart about type 1 and type 2 error. You can read what it has here. The prom committee has been told they can only have post-prom if more than half the students attending prom are also going to attend post-prom. They only have an hour to make their decision, so they have to take a sample poll of students. We can't ask everybody. Write a hypothesis. So remember, your null hypothesis is always in equals. So we're going to say the 50%. We're hoping that we have more than half, so greater than 50%. There's nothing to type in your calculator. We're just going to talk about what an error means. Maybe this would be helpful. If this is true, they can host post-prom. And if this happens to be true, they cannot have post-prom. So a type 1 error is when you reject the null. So if you rejected the null, we would think, yes, we can have post-prom. So you'd reject the null and have post-prom, but the consequence is less than half show up and the committee loses money and other consequences like that. A type 2 error is the complete opposite. You fail to reject the null, meaning that we don't have post-prom, but the consequence is we should have, because more than half would have come and it would have been a good time or whatever. So you're going to have a question like that. Good luck, and that's it. See ya.